Thank you. Thanks, Bill. Thank you, everyone, for being here. I know this is it's a very tough one. It's the last slot of, huh? Yes, I'm sure the storm has helped. But I'll try to finish earlier before the deadline, and then you can get to your dinner faster. Okay, so I assume a lot of people here have been to the other R-related talks. So this is going to be a little bit more focused on the specific API that has recently been introduced in SparkR, and the talk is primarily based on our experience working with customers that have been using the new API. So hopefully it'll be very hands-on and useful. I'm going to skip this until someone raises their hand and says they don't know what SparkR is. Okay, there's at least one person. So SparkR is an R package that is distributed with Apache Spark, and very soon it will be on CRAN as well. It provides an R front end to Spark data frames. And offers other functionality in addition to just the data frame API. Basically, with SparkR, you get the good things that come with Spark plus all the nice things about R. You have distributed robust processing engine, a lot of data sources, off-memory data structures, and then on the other hand, in the R world, you have a dynamic interactive environment, visualizations, packages, and whatnot. Because I'm going to go into some details about performance, I have to make sure that we are on the same page about the architecture. So this might be a little bit high level and boring, but please bear with me and we'll use it again. This is from 1,000 feet, the general architecture of Spark. We have a driver that runs a JVM process, and a bunch of workers that each have a JVM process. When you introduce SparkR into the picture, it changes like this. You have an object inside the JVM process of the driver called the R backend, and you have an R process. That's where user will submit their R commands, which will be sent over local socket to the R backend in the JVM and translated to native Spark API calls and executed on the workers. And because this is Spark, you can read data from a variety of data sources into the workers. So what I want to emphasize here is that normally when you are interacting with data, distributed data, the data is being handled by the JVM of the workers. There are two things. First is the worker, second is the JVM. Okay. Since Spark 2.0, we have the ability of running ephemeral R processes on the workers. And that's what enables the new UDF functionality in SparkR. So I use this slide to show a broad categorization of SparkR APIs. We have APIs for reading and writing data, distributed data. We have functions for caching and persisting data, SQL-related ones. Wrappers for machine learning, as Felix talked about him this morning. That list is a lot larger than what you see there. You have data frames APIs, and finally we have the new UDF API, which is available since 2.0. So let's talk about those. What are they? They're in three buckets or three types of general types of UDF functionality. The first one is SparkR API, and what it does at a very high level is running a Spark function over elements of a list in a distributed fashion. There's only one function in this category. The second category is the Dapply category, and what it does, it applies a function to every partition of a distributed data frame. And there are two functions in this category, Dapply and Dapply collect. And I'll talk about more details of these. And then the third category is gapply, and that applies a function to every group within a Spark distributed data frame. And again, we have gapply and gapply collect. So let's look at more details of each one of these. And what I will do, I'll explain what it does, basically the semantics, and then I'll show how it does it, so we understand what happens under the hood. And the reason I'm doing it, based on the experience we had with our customers using this API, not knowing what happens under the hood has the disadvantage of abusing or misusing the API, which leads to either failed projects or very slow jobs, or dissatisfied Spark users, or or wasted resources. So we just want to help people understand what happens so they choose the API the right way, and they pick the right API and they use it the right way. So let's start with the first one. It is the simplest UDF pattern. You give it a list as the first argument, and you give it a function as the second argument. It sends the function to all the workers in your cluster and executes that function over one element of that list. And then you get the result back in your driver as another list. And this is the signature. Basically, this is telling it for a list of 1 to 100, run this function. So as I said, this is the simplest one and very easy to understand. But what happens under the hood? Let's go back to our architecture diagram and imagine a user typed that snippet of code that I just showed. The first thing that happens is that the SparkR package on the R process will grab the user's function and find out what variables in that namespace it depends on and put them all together into something which is called a closure. It'll serialize that closure into a binary array. So we have binary data at that point. It'll send it over the local socket to the JVM. Now the JVM just received a blob of binary data. What it does, it will just send it over the network to every worker. So on each worker, what happens, the JVM receives that binary and then just sends it over the local socket again to the R process. I'm skipping one minor step here, which is it might have to launch that R process and whatnot. So at this point, the R process just received a blob of binary stuff. It will deserialize it and get back that function again, plus all the variables that that function depends on. And at that point, we have a function that can be executed. The R worker will just execute that function, and that function is going to return something. It will, again, serialize the result of the function, send it over the local socket to the JVM. JVM will send it back over the network. The driver JVM gets it, sends it to the R process deserializes it. And now we have the result of one of our workers. SparkR package on the driver will put them all next to each other into a list, and then we'll return that to the user. So you get the result of your SparkR API. So I did go through kind of more details than usually we want to think about, but I'm not going to repeat in so many steps. But basically, we can understand that serialization happens, transfers over network happen, deserialization, execution, and then the whole path back. So let's talk about Dapply. Dapply takes two arguments in a high level, a Spark data frame and an R function. It'll take each partition of that Spark data frame and send it to an R worker, execute that function on that worker, and then return the result. And there are two scenarios. The first scenario is that if you want to get back the result of that function in the form of another Spark data frame, in that case, you need to specify a third argument, which is the schema of the return data frame. The second scenario is in which you don't want a distributed data frame as the result. You just want a normal R data frame. In that case, you don't have to specify the schema. I'll explain why you need to specify the schema. So let's go to our architecture diagram again and see what happens here. I'm going to be a little bit more high level here. The first step of the control flow, by control flow I mean the function, is sending it from the R process to the JVM. Obviously serialization happens over the network, and from the JVM to the R process, and then deserialize again. Okay, so now at the R process we have our function to be executed. Now we need the data. The data is already inside the worker's JVM, right? That's what I meant by that emphasis on the fact that data is being handled by the JVM. So JVM and the worker already has a partition of our data. It serializes it and sends it over the local socket to the R process, and the R process knows how to deserialize it to a local R data frame. At that point, our function gets a local R data frame, so we have the code and we have the input to the function, and we execute it. And we end up with some result, which is going to be also in the form of a data frame, because that's the contract of Dapply. The result is then serialized in the R process and sent back to the workers to the JVM process. Okay. At this step, the JVM receives a binary blob of data, right? And it's supposed to understand it, basically deserialize it. And that's why you need to tell the JVM how to deserialize that. And the way you tell the JVM how to understand that blob of data is by telling it the schema of the data. Basically, the JVM knows this is supposed to be a Spark data frame, and therefore it's a bunch of rows, and each row has a bunch of columns, and then it needs to know what is the name of each column and what's the type of each column. And that's what the schema, the third argument in Dapply is used for. Okay? However, when we use Dapply collect, we don't need that. We don't need the JVM to understand the data. It basically just sends it back to the driver, and the driver JVM sends it to the R process, and the R process receives a binary blob, and it knows how to deserialize it back to an R data frame. That's why we don't need the schema. So that's how Dapply works. Dapply is the third one, which is sort of similar. The main difference is that you specify a column name, one or more. It will first perform a grouping on that column name, and then for each group within your Spark data frame, it will execute the function on the group. Again, we have two signatures. The normal Dapply takes a Spark data frame, takes one or more columns, a function, and a schema in order to return a Spark data frame. And the Dapply collect signature is just like the previous one without the schema, because you end up with an R data frame in your driver. And the control and data flow is very similar to, the control flow is exactly similar to Dapply. The only exception is during the data flow, we first perform a group by operation. Basically, that's an all-to-all communication between all the workers. That's a shuffle. And then each worker will have all the data corresponding to each value of the column. And then we just behave like a normal Dapply. Okay, so now we know the semantic of each of these calls, and we know what happens under the hood when the user calls them. And so far it's good, except that I have seen people by mistake use Dapply and Dapply instead of each other. And that is a common problem. So it helps to clarify the differences. The first obvious difference is the signature, the function signature. Dapply takes a second argument of columns, Dapply doesn't. However, there is another version of Dapply that doesn't take a list of columns, and instead it takes a grouped data frame. And that has been somewhat confusing to some users. Basically, what you can do, instead of having Dapply perform the grouping for you, you can use the group by function in SparkR, give it a data frame and a bunch of columns, and that returns you a grouped data frame, and then pass that to your Dapply. So that's the first difference between the two. The second, in terms of the user function signature, the function you pass to Dapply takes two arguments. A key and the data. Basically, every worker will be given a partition of the data that corresponds to a unique key. and the worker knows what key it's operating on. On Dapply, we don't have that. You only get a data frame. And finally, the data partitioning, and this is basically a semantic difference. The data partitioning in Dapply is controlled by the grouping operation. In Dapply, it is not controlled. And that has been a major source of confusion. I have seen a few users just start with Dapply and then be surprised, why am I not getting the result I'm expecting, and turns out their data was partitioned in a way that they didn't expect it. So that's how you can, those three things will help you choose whether you want to use Dapply or Gapply, okay? But now this is the main part of my talk. I'm going to go through a bunch of things we learned on the field. With this knowledge we have about these functions, we'll understand why each of those is going to be helpful. The first thing is about parallelizing data, or distributing data, or basically tips and tricks about the data flow when using the UDF functionality. Number one, do not use Spark API to distribute large amounts of data. Let me tell you an example, or how people actually do not respect this rule. I've seen people take their data, like let's say 10 data frames, put it in a list, so they have a list of data frames, and then use Spark API on that list to, in parallel, process their data frames. The problem with that is Spark API, as you saw, sends everything in the control plane, basically. It sends everything as part of the closure. So that list you give it will be somehow packed into the closure. And that is not an efficient way of distributing data. If you put too much data into that list, either it will be very slow, or it will just blow up, and you get errors. So that's not the right way of processing large amounts of data. Another common mistake is, by mistake or intentionally, some users pack data into the closure. It ends up with the same problems as the previous one. But the way this happens, like the way people make this mistake, is a little bit different. Sometimes you're writing a Spark program in R, and you're writing a function that you're going to use in Spark API, Dapply, or Gapply. And in that function, you reference a variable. And Spark R is smart. It's going to take care of shipping that variable to my workers. That is true. But if that variable points to a data frame of, say, 30,000 rows, then you're shipping a lot of data through the control plane. Again, it could be very slow, or it could just blow up. So don't do that, and I will talk about how to avoid that. Number three, something that surprises users of this new API, is sometimes they see it's very slow. And I don't know, it goes all the way and then it stops. And then I have to wait a few hours for it to finish. And that's when a customer explains that scenario to me, my first question is that, is your data skewed? Or the other way to ask is that, do you know how your data is partitioned? So many times when people read their data, they perform some filtering on it, and then they end up with a smaller data frame, Spark data frame, and then they want to use it in one of these APIs. Filtering, sometimes you will end up with many small partitions and one huge partition. So as a result, that worker that has to handle that single partition is going to take a lot longer than all the other workers. So all the other workers will finish, and then that worker will be processing most of the data. Another possibility is that you're using Gapply and you're grouping by one of the columns. What happens is that that is skewed, so you end up with one group with most of your data. Again, you'll face the same problem. And finally, when you have to use auxiliary data, this is mostly for Dapply or Gapply, either create a joint data frame or use distributed file system to distribute that to all your workers. And this kind of relates to the second point. This is why people reference variables in their function that ends up packing a lot of data into the closure. They want to, let's say, they have an input Spark data frame, and they have a helper data frame that has to be joined in some way with that input data frame. And they want to send it to all the workers, so they just use it in the function. Okay? There are two ways of not doing it. One, you could just join the two data frames and then give that as the input to your dapply or gapply. Sometimes that doesn't work because there is an all-to-all relationship between that auxiliary data frame and the input data frame. And in that case, you could persist your auxiliary data and read it on the worker. And I will show you how you could do this in the demo part. But basically, the message is that at all costs, avoid packing too much data into your closure. All right. The next category of lessons we have learned is around packages. The SparkR implementation of the UDF functionality is pretty smart. As I said, it takes care of finding out all the dependencies of the function that you're giving it, except when you use packages or third-party packages. When you use third-party packages, you need to, first of all, import that package on the worker process. And there is an interesting nuance to that. Because the worker process is ephemeral, for each execution of your function, you need to import it again. Because the next execution of the function on the same worker is basically a fresh R process, right? And finally, if that package is not installed on the worker, you need to install it. So the fact that you install the package on the driver doesn't mean you have access to that package and its functions on your workers. What I usually recommend is using Spark Apply to install packages on the workers. Again, I can show how this would work. All right, the final set of common questions I've got, and I think it will be useful to share with you, is how to debug your code when you're using one of these functions. These are the things I usually tell people when they ask me this question. First of all, these are the steps I go through when I face this problem. First of all, I verify my code works on a single node, and that is the driver. That just makes sure that the function is working. Then I interactively execute the code on the cluster. Sometimes people run these as jobs, and it fails, and then they end up with a job failure and lots of messages, and that's kind of harder to debug. So doing it interactively, you know exactly at what stage of your code it failed, and you can hopefully debug further. What happens when the UDF function fails? The driver will return an exception. It is literally a Java exception that is thrown in the R process, and that's a source of confusion for many R users because they end up with an error that they're not familiar with. They see package names in it. But that exception, if you search, will include the error message from the R worker. So if you search enough, you'll get a very good clue on what went wrong. The other thing you could do, in the Spark UI, you can see the details of failures. So if you go to the job details on Spark UI and you click on your failed job, you can see more details why the job failed, and that exception will include the error message from the R worker. And finally, depending on the type of cluster manager you're using, in different ways they allow you to see the standard error and standard out of your R workers. So that'll help you debug it as well. All right, so I have a very, very short demo, and the purpose of the demo is just showing this API and going through some common problems that we see. I'm going to use, is it visible? Can everyone read it? Okay, great. I'm going to use the Databricks Community Edition. It's a tiny cluster. As I said, these are all toy examples, and we'll just show you how you can use the API. First, I'm going to show how to install a package on your workers. this is very simple. SparkR apply, list of 1 and 2, install this package, and then import it just to make sure that the package is properly installed. So let's run that. It failed. So now, I'm the user. I just tried to install the package, and I got a failure. What should I do? The first recommendation to all users, to our users, is do not rush to find the error. This is going to take a little bit of searching, and that's because when you expand the error, you see a lot of text, and you'll see an exception. But you need to just very calmly continue searching and be patient, and search and try to find what happened. And then here you see caused by our computation failed with installing package into this place. Lib is unspecified, content type, blah, blah. Error failed to lock. Okay, so here it says I couldn't lock this directory. So that's basically what is causing us to fail. But why is that? The reason is here I have a mini cluster with only one worker. And I am giving it a list of size 2. And it tries to simultaneously install the package on that single worker. And it fails. So let's try only one. By the way, the fact that this is a cluster of size 1 is something I know about my cluster because I launched the cluster, right? And this time it succeeded, so I could import my package. Now, let's use it. So let's change this to 1 as well. And here, I am going to use the example that we saw this morning in Felix's talk, and just call this on the worker. And again, we see a failure. So let's see what happened here. Could not find the package. And this is what I meant by you have to import it. Although I've already imported that in my previous call, that doesn't mean it's going to be available in this call. These are ephemeral R processes. So if I say library and then run it, it'll succeed. Okay. Hopefully that example showed what sort of problems you could see and how to debug them. This is going to show us how some similar examples with dapply and gapply. So I'm going to just create a very small toy Spark data frame and use gapply to just count the number of rows corresponding to each type, each value of the species column. So let's run that. As I said, this is a very tiny cluster, so you have to bear with it. And this is community edition, so it's free. You can log in and try these things. And I will publish these notebooks and put them on the slides before we publish the slides, so you can try them out. How big is the data set? It's very tiny. It's, the iris data set is 150 rows. Yes, it's tiny. As I said, you remember all those serializations and deserializations that happen? So sometimes it doesn't, if you have really tiny data, it's not worth going through all that fixed cost. So this is how it works. You basically get 50 rows for each species. So that's how gapply collect works. You see, I get back a Spark data frame with the key and whatever else I want to put in it. So let's do that with dapply. So df was the data frame I just created, and I just do the same thing. And here I get one row with 150 in it. The reason is this Spark data frame is just one partition. That's what I meant by a lot of the times you will be surprised by how your data is partitioned. You can never assume your data is partitioned the way you expected. You always have to explicitly control that if you rely on the partitioning, because Spark is taking care of that for you, right? So what I can do, I can repartition my data. There's a function called repartition in SparkR. You can give it a column or a number. If you give it a number, it will just randomly repartition your data to generate that many partitions. If you give it a column, it will use that as a group by and repartition to that many groups. And I do the same thing. And note that here I'm doing dapply, so my function signature just takes one argument. Thanks for your patience. In this case, it is actually sending the data over, serializing and sending it over the network to the worker and then sending it back, sending the results back. It's basically the fixed, yeah, exactly. The amount of data is very small, but the overhead of yes, is a lot. And then here you see, again, I get the 350s. Basically, my grouping generated 3 partitions, each of the same size. Okay? So now let's try the other flavor, which is not collecting the result. And that flavor, basically you specify a schema, and this is the syntax. You have a struct type, and in that there are a bunch of struct fields, and each one of them has a name and a type. Okay? And I have a simple function, a simple gapply. I give it species, and I produce a data frame with the key and the number of rows. And I want to get that back, that simple 3-line data frame as a Spark data frame, right? So let's run it. And now, you notice this is lazy. The reason is, you don't have to, basically, what you get back is a reference. If I type it here, it just says it's a Spark data frame that has 2 columns of these types. It hasn't materialized it. Nothing has happened, right? So in order to materialize it, I'm going to call head on it. And you can see what it's doing, and we got an error. Let's look at it. This time the error is actually, you don't have to scroll too much. You can see that it says unsupported type for serialization factor. Does someone have a guess what's going wrong? What's the problem? Yeah, it basically can't serialize. One of those serialization steps is complaining that I cannot deal with factors, right? And turns out when you use data frame and give it anything which is a string, it'll do a factor. So let me prove it to you. If I do str data frame x equals 1, you see it's a factor. So there's a solution to that. Strings as factor, is that? Let's double check here. Oh, that's right. I want the opposite. And, Oh, correct. Right. Data, let's do this. Data. It's SS, right? There you go. Here we have it. Yep. And we do want, there you go. So now, just do the same thing here. And if we materialize our result, hopefully this time it works. Spark UI, and you can see that it's actually there you go. So we got a Spark data frame, and then we could materialize it. All right, the last thing I want to talk about is how you can distribute auxiliary data to your workers. Here, the example I'm going to show is by writing the data you want to distribute to all workers to distribute file system, and then reading it individually on the workers. So let me create a directory. I am dealing with distributed file system, which is backed by S3 here. I create one, and then I just write the iris data frame that I created using Spark CSV data source into this location. And then I just want to find out exactly what the path is. And as you can see, it has generated a random file name for it. So, and it is a single file name. Again, this is something you cannot assume. If my data was repartitioned to have 3 partitions or 4 partitions, I would have ended up with 4 files here. So I take that file and use it inside the function. Okay? So now, basically, here's what I'm doing is I'm using Spark Apply. In the function for Apply, I'm reading this, and I'm using read.csv. This is local file. Right? So what's happening here? /dbff is a fuse mount point. How many of you here have heard of fuse file system? Okay. So basically, it is a local file system that points to a distributed file. Okay? That allows my R process to just treat it as a local file. It doesn't have to understand Hadoop. That's why I can use read.csv. So I read it as a normal local data frame, and then I do something with it. So if I execute it, and this time it's way faster, you can see both workers or both instantiations of the worker process got the result. All right. And that is our demo. And I would be glad to take any questions if there are any.
Let's give him a hand. I think that was probably the most detailed, basically version or explanation of how the whole R process actually works with Spark, and I think that that's really, really valuable, so I would definitely focus on that. Somebody had a question back here? Doug?
So 2 questions. One was, if I'm running in local mode, do I still have serialization between the driver and the executor?
Yes, because this was a decision that is overarching in Spark. The Spark local mode goes through the same code path. So that local mode is mostly used by developers for debugging in order to help them debug their code. It goes through the same code path. So basically, it goes through the local socket.
Wondering for the last part that you showed, what is the difference between this, like reading from the workers versus like doing the Spark context broadcasting feature?
As far as I know, the broadcast feature is not available in Spark R, especially for the UDF functions. So that's kind of a workaround.
Would that demo that you showed would work in my laptop if I have Spark and everything set up?
Yes. Yeah.
Okay.
So it's a free service. It's online. Is there any other questions? Question? Oh, sorry.
This lady over there.
Yeah, I'm going to.
Thank you, Bill.
So I'm still a little I have two questions. I'm still a little confused about the difference between gapply and dapply, because I feel like you said a lot of people get it confused, but I guess I would have liked to see maybe an example of like how to sort of distinguish or understand which particular instances one function is better versus the other. And then the other question I had is, there was a talk on, I think, Sparkling R, so the R Studio people are also actively working on Spark development and R integration. So I guess there's SparkR and then there's Sparkling R, and so I guess I'm just curious how you, I assume they complement each other, but I don't know, there might be duplications as well, or like how would an R user go about using Spark? Like, should they be working with both packages?
Okay, so on the first question of dapply versus gapply, my general rule of thumb when I talk to a new user is that you probably want to use gapply, because that with gapply you're explicitly controlling what data goes to what function, what worker. The cases where you're okay with dapply is actually much more rare than the gapply cases. Yes, yes, it will shuffle your data. Yes. That is a Spark job. Spark will take care. If you're dealing with lots of data, you hopefully have a large Spark cluster, and Spark is optimized to do shuffles. So it is pretty good at doing it, and let it do it. So if you want, in order to get the correct answer, you need to control all the data that go together into a worker. And the way you control it is through basically a shuffle. Okay?
So dapply, right?
No, gapply basically performs that shuffle for you as part of the grouping. So the question is there a reduce by in SparkR? There is reduce by in the data frame API. But that takes an expression and not a native R function. On the second question about Sparkly R, so you could see that there is a lot of overlap. And in this talk, I didn't focus on the overlap. I'm basically entirely focused on the UDF functionality, which is a part that there is no overlap. This is something that SparkR does, and Sparkly R has, the way it has been designed, hasn't got there yet. I don't actually have an answer as to which one to use. I think at the end of the day, it's the user's choice. Some people like that style or that syntax a lot better. Some people want to use some of the features that are here. So I agree that this is very early stages of both packages. So it is natural that there are multiple choices. And it may continue to be like that because they're focusing on different things. So you're lucky to be at the forefront. So that's why you have that question.
So my question is still regarding with the gapply. What if after you shuffle, a certain group of data does not fit in that worker? Would that be a problem?
I think it can be a problem, yeah.
Okay. Yes.
That will be a problem.
I kind of think I might have answered this in my own head, but would there be any advantage to persisting that R session on the worker nodes, but past you said it's associated with the JVM of the Spark executor, right?
Oh, so you mean why are the R workers ephemeral?
Well, I get why the functions are, but I'm thinking so we've got some R packages that take a kind of long time to install, and the fact that every time you reinstantiate a Spark executor, right, you have a Spark context, it goes away, it comes back, you'd have to reinstall those R
You don't have to
libraries.
reinstall. You only install once, and that installs it on the machine.
Okay.
But you just have to import them again.
So if it was like kind of like an elastic environment though, where those machines are sort of going away, and
Yes.
I guess it wouldn't help anyway.
Absolutely. So we actually see that problem. With clusters that scale up and down, you think you have installed your libraries on all the workers, and then in the middle of the night, you get paged because your job failed and because there were new workers that didn't have it. So if you want to be extra safe, you want to install it as well, right? Or check. See, if it's not, if I cannot import it, then install it and import it. And that will you won't pay the cost if you don't have to. But you know why the processes are ephemeral, because we want to separate state. We don't want leftover state from the last execution to affect the next execution.
Cool. And I think with that, let's give Hossein another round of applause, and we'll call it for this Spark Summit.